In today's lesson, we're going to learn about solving quadratic equations, specifically by using the quadratic formula. There are some quadratic equations that cannot be solved by factoring, as we learned previously. For these equations and all other quadratic equations, we can always use the quadratic formula to solve. Luckily, the quadratic formula will be given to you on the SOL formula sheet, but it is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And it only is going to happen when ax squared plus bx plus c is equal to 0. So that's going to be always our step number one, is to get it in that standard form with ax squared first, then bx, then c, all must equal 0. So that's going to be a key factor we keep moving forward today. From here, we're going to identify a, b, and c like we have done before with factoring, but then we will substitute into the formula. After that, we got to use some PEMDAS and Desmos to get x solved. When we're solving for x, we can always check our work in Desmos by looking for the x-intercepts of our graph. Sometimes on the SOL and in our problems today, x-intercepts will also be known as the following, which is the acronym of ROX. ROX is going to be roots, as well as zeros, as well as x-intercepts, and as well as solutions. When you're checking your answer in Desmos, you'll use the graphing calculator as you see pictured to the left, and you always look for the x-intercepts, which are the points that cross through the x-axis, to be your answers. Alrighty, let's try example number 1. So again, first step is to get it into standard form, which means I have to have this equal to 0. As you see, it's equal to negative 15, so I must get one side equal to 0. The easiest one is to make the right side equal to 0 by adding over 15. Negative 15 plus 15 does equal out to 0, so that's why I chose it. Plus, it will move the 15 term to the other side. Remember, it must be in standard form, so I'm going to keep my exponent term, the n squared, first. Then my regular letter term second, and I will be adding 15 at the end. From here, we identify our A, B, and C. A is going to be the number on the first term when there's no number. Remember, it's a 1. The B term is going to be the number on our second term, which is going to be 8. And then C is going to be the last term, which is going to be 15 in this case. Now that I have my A, B, and C, I go right to the formula here. I'm going to write down the formula just because I like to show it again, even though it is right to the left of us, because I like to show where I'm replacing all of these into. Where I have B in my formula every time here, I'm going to replace it with an 8. So I'll keep the negative, but then I'll replace an 8 here. And then I'll keep the plus or minus. We'll see what that looks like later. And now I'm going to use parentheses when I'm substituting the 8 into the squared. So I'm going to keep the negative 4 always. But instead of A here, I'm going to replace it with A that I have, which is going to be 1. Every time I'm replacing, I'm going to be using parentheses here. When I use substitution, I like to do parentheses every time I'm replacing that letter of A and B. Last but not least, I'm going to have C that I need to be replacing with my 15 here. Okay. I very much will use Desmos for a lot of this here, but I will do some of it by hand. I'm going to keep the x equals, and I'm going to make sure to adjust what's in front of my plus or minus as a negative 8. I'm going to adjust my denominator. 2 times 1 we know is 2. And now I'm going to keep this radical, but I'm going to go to Desmos to do everything underneath it. So all of this in green, I'm going to put into Desmos, and I'll show you now. Everything in green is going to go in Desmos, so I do parentheses 8 with my square term, and I subtract 4, and A was 1, C was 15. And remember, when I plug in B, A, and C here, I use parentheses to make sure I get the right answer. That's going to appear under my radical. So now when I go back to my notes here, everything under the radical simplified to the number 4 that we just got in Desmos here. I now do the square root of 4, which I can do in Desmos to get 2. So now I'm going to go and do the rest by hand here. X is now equal to my -8 plus or minus the square root of 4 here being 2 all over 2. Now I'm going to deal with this plus or minus here. When I have this plus or minus, it means I'm going to have more than one answer. A lot of the time, not every time, but a lot of the time I'm going to have more than one answer. So that's now going to be needed to be solved for both. The first answer is -8, keeping that -8. But in that plus or minus sign, I'm going to take the plus sign option of 2 all over 2. Then I'm also going to solve this again with -8 still, but now a subtraction of 2 instead of an addition to 2 all over 2. So I have to solve both. The top one, it's -8 plus 2, which is -6, divided by 2 gets me a -3. In the bottom here, a -8 minus 2 is -10, divided by 2 gets me a -5. You can always do that in Desmos as well, or in a calculator to check your math of those two. Now we're going to check our answer in Desmos by typing in the original problem here. When I type in the original problem, it's n squared plus 8n equaling a -15. I make sure to use the error message of only support implicit equations of x and y to change out my n to x. I check on the graph just like I saw in the front of my notes for my two answers of -3 and -5, which is what we just got. Okay, let's try the next one. In the next example, we're going to find the roots of -14r plus 7r squared equaling a -7. Remember, to get it in standard form, it has to be equal to 0, and we just said it was equal to a -7. So the first thing I'm going to do is I'm going to add over 7 to the other side, because -7 plus 7 will get me 0 on the right side, and I got to make sure it's in standard form on the left side. My x squared term will go first, so I'll have 7r squared. Then my next term with just a letter and no exponent will be written. And don't forget, when you add 7, you have to do it to one side and the other side of your equal sign. And we will write it at the end. Now, in the last example, we didn't have this step, but it is important to check for the greatest common factor if possible. It wasn't possible in example number 1, but here it is possible. I can see and look at all of these terms and see that they are all divisible by a 7. So what I'm going to go ahead and do is divide every single term by 7, taking out that greatest common factor. Because it has an equal sign, I can do it on every single term and side of my equation, and it will end up going away. I will get the result left of actually dividing out that 7 from every term. 7 divided by 7 is 1 with my r squared. -14 divided by 7 is -2 with my r. And a positive 7 divided by 7 is a positive 1. On the right side of my equation, I know 0 divided by 7 is going to be 0. Now it just allows me to use smaller numbers for my a, b, and c in my quadratic formula. Now, if you didn't take out the greatest common factor, you would still get the same answer. You'd just be having to deal with larger numbers. And you wouldn't make sure to take out the greatest common factor, which is always a good step to do in factoring and solving. We are now going to list our A, B, and C. A is the number on our first term, which is now the new number of 1. Then I'm going to look at my second term and take the -2 on that R. And the last term is going to be plus 1 for my c. Now that I have my a, b, and c, I go right to the formula here. I'll keep x equals with my fraction. I'll have a negative parentheses b in place of that letter because, again, always trying to change the quadratic equation from letters to numbers. I'll keep the plus or minus in my square root. Underneath the square root is going to be a parentheses of negative 2, and we're squaring it. That comes right from b squared in my formula. Minus 4 is under the radical in my formula. Next to 4 should be my parentheses a, which is 1. Make sure when you're substituting, you always use parentheses to get it right. Parentheses next to 1 should be 1 as well for my c value. And then I go all over my 2a. 2 stays because it's part of the formula, and a is changing out, substituting to 1. From here, remember, we got to clean this up by doing sum by hand. We do the first part in front of the plus or minus. We know 2 negatives will make it a positive 2. In my denominator, it's 2 times 1, so that would be 2. And remember that I'm going to put everything under my radical into Desmos. Let's do that now. When I type that in Desmos correctly in parentheses, I get 0. Notice that in line 2 on Desmos, I typed it in without my parentheses at all. Notice that I get the wrong answer. So that's always showing you need to put parentheses when you're substituting in, or else you're going to get the wrong number under your radical. So my correct number under the radical is going to be 0 here. We then take the square root of 0, which is just going to be 0. And then I'm able to actually break this up into my 2 possible answer options. Remember, the first option is x will be equal to a 2 plus 0 over 2, because that's the plus of this plus minus sign. And I also know that it's going to be 2 minus 0 over 2 equaling 2rx here. Because again, I'm taking the minus of that plus minus option. In the top, 2 plus 0 is 2. Divide that by 2, I get 1. And my second answer is going to be 2 minus 0, which is 2, divided by 2, which is 1. So actually, that is going to be only one answer for this problem, and the answer will be 1. You don't need to write it twice. I'm just showing you that it comes out to 1 both times. So again, we go ahead and plug in the original problem into Desmos. As I see, I have an error message saying that I need to have it in a different format. So that usually is talking about that I need to replace our variables with x. So I'm going to go ahead and replace every time I have r with x to get my final answer. As you see, the only time it's touching the graph, if I zoom in or zoom out, will be that answer of 1. Let's go ahead and try the next example. Again, first step for example number 3 is to find the zeros of 6x squared plus 2x plus 9 equaling 12. Remember, it has to equal 0 to be able to be solved with a quadratic formula or even by factoring. But we go ahead and do that by getting one side equal to 0, which is easiest on the right side for this problem. Easiest way is I have a positive 12, so I subtract 12 to get 0 on the right side. And what I do to one side, I must do to the other. Now I'm going to make sure it's in standard form, so my x squared term is going to go first of 6x squared. My x term is going to go next, so that's going to be 2x. And when I do my c here, I see that I have a 9 that I must combine with my other number that I moved over to that side of negative 12. So I do 9 minus 12, which will be a negative 3. My a is going to go ahead and be 6. My b is going to go ahead and be 2. And then my c will now be a negative 3. So it's really important to get it in standard form, or else we might have had the wrong A, B, and C for this problem. Once I have A, B, and C, I go to the formula, which is x equals my negative in place of that B is going to be a 2. In place of my B squared underneath the radical here, I'm going to have a parentheses 2, and don't forget to square it. Then I'm going to keep going with my formula, minus 4, but then after 4, I'm going to have a parentheses of A, which is 6. And next to my parentheses of 6, I will also have my C multiplied as well, which is negative 3. Last but not least, I will go ahead and have the denominator here be 2. That's part of my formula. And in place of A will be a parentheses 6. All right. Now we go ahead and clean this up. Remember how I clean it up is I'll keep x equals here. But in front of my plus or minus, I'll get the actual sign here, clean it up to negative 2. Remember, I do the denominator by hand as well because I know 2 times 6 comes out to be 12. But now I go to the Desmos graphing calculator to type in everything in green. That's going to be under the radical one number when I type it in Desmos. Let's do that now. As you see, we type in everything we just highlighted in green. It is parentheses 2 with a squared, minus 4, parentheses 6, then parentheses negative 3. You must have all the parentheses, signs, and exponents to get the same answer. Try it yourself. Make sure you get a 76 that will place under the radical. Now that our radical is down to one number, I'm going to see if I could do the square root of 76, because last time we did the square root and it worked out. Here I'll do the square root of 76. When it comes out to a decimal, I'm going to leave it in a radical format. So I'm going to leave it as radical 76. What I'm going to do from here is then break up the plus or minus because I'm keeping the radical. It can't come down to a number. So I then go to my next step of the two answers. Well, my first answer here is going to be x equals the negative 2 with the plus option on top of that minus, square root of 76 all over 12. My second answer is going to be x equals negative 2. Now take this subtraction option instead of the plus option of radical 76 all over 12. That's going to be my two answers here. When I check this one in Desmos here, I'm going to type in the original problem. Let's go for it here, where I'm going to have a 6x squared because I have x, I don't have to change it out, plus 2x. The original one given plus 9 equaling a 12. Type it in just as you see it. When I'm zooming into my answers, you will see I get those decimals. When you actually type in the two purple ones we have, we're going to get those same decimals. Let's check it out. So let's try the first one of negative 2 plus our square root of 76. You will have to highlight the whole thing to be able to divide it by the whole fraction. So like I said, I highlight the whole thing to do division, and in my denominator is a 12. As you see, that's 0.5598, which is the answer for this one just rounded. Then I'll go ahead and just change out the plus to a subtraction to check that my second answer is the one I'm getting on the graph. As you see, they match a negative 0.893. For this problem, I'm finding the x-intercepts of x squared plus 7x minus 10 equaling 0. Because I already have it in standard form and equal to 0, I can go straight to step number 2, doing my A, B, and C. A is going to go ahead and be 1 for this problem here. B will go ahead and be 7. And C will be, make sure to take it the negative with your 10. Now that I have this, I'm plugging it into the quadratic formula. I'll keep x equals with my fraction. I'll keep the negative, but in place of b, I'm going to go ahead and put a parenthesis 7. Make sure to use parentheses when you're substituting these numbers in for the letters. because we're changing this whole kind of formula to all letters. And it's going to be plus or minus the square root of, instead of b, I'm going to have 7 that I will square. Minus 4 will stay, but in place of a will be 1. And in place of c will be a negative 10. It's going to be all over 2, and instead of a, I'll put a parentheses with 1. From here, I'm going to go ahead and simplify this down. Remember that I changed what's in front of the plus or minus to a negative 7. In the denominator, 2 times 1 I know will be 2. And remember, we put everything under the radical in green into Desmos. You can pull up Desmos if you'd like to follow along, but it's going to be parentheses 7 squared minus 4 parentheses 1 parentheses negative 10. Everything under my radical now is going to be changed to an 89. Once I have 89 under here, I'm going to try taking the square root of that 89 again in Desmos. And if it comes out to a perfect number, great. When it's a decimal, remember, we'll leave that radical here. I got a breakup for my two answers, which will be, first answer is x equals negative 7 plus square root of 89 over 2. And I will also take my x equals negative 7 minus a square root of 89 all over 2. So you got to take both options with the positive and the negative in front of your radical. Let's go ahead and try example number 5. I'm trying to solve 10x squared plus 3x equaling 0. I want to make sure it's in standard form, and it is equal to 0 as I just said. And I know that the x squared term is first, so that will be what I get my a from. My bx term is second. That's what I'm going to get my b from. And notice how there's going to be no c value, so we'll be plugging that in for 0. I'll check if there's a greatest common factor if possible. Always want to do that. But I look and see I have the numbers of 10x squared and 3x. So that's not going to be divisible by a common number. They both do have an x, but I want to keep it in this standard kind of format. Only looking for our numbers greatest common factoring out. So I'm going to write a as, like I said, my 10 because that's on the x squared term. My b in this case is going to be 3 because that's on the x term. And because there's no c term, we still want to use a number for it, but it will be 0. We go ahead and substitute that in the formula. X equals a negative b, so that will be a negative parentheses 3. Plus or minus stays like it is in the formula on the left. Do the square root here because inside is going to be b that I'm squaring, so 3 gets a square outside of those parentheses. We subtract 4, and I'll put parentheses a, which is 10, a parentheses c, which is 0. From here, we go ahead and put it all over a 2 parentheses a. Now we simplify this down. X will equal a negative 3 in front of that plus or minus. Remember, we'll put what everything under the square root highlighted in green is in Desmos to get one answer, one number under our square root. And in the denominator, I actually do 2 times 10, which is 20. From here, I go to Desmos, and if you've been doing Desmos the whole time, the pretty cool thing is that I can just change out the numbers from the last problem in my parentheses to get my answer. So all I'm doing is deleting what I had for B, A, and C last time and replacing my B, A, and C that I have this time. I see that underneath my radical is 9, and I can't forget that I'll also take the square root of that to see if it comes out to a nice number, not a decimal. Then I can actually replace it in place of our whole square root of 9. So remember that everything under the radical became 9, and I know the actual square root of 9 is 3. And I'll keep everything else that we had, which is the x equals negative 3 plus or minus that square root of 9, which is 3 we just found. all over 20. Remember, now I break it up into my two answer options. X equals a negative 3 plus 3 over 20. That was the plus sign of our plus or minus. And then separately, I have to also write that x can be equal to my negative 3 minus 3 all over 20. Over here, negative 3 plus 3 is 0. When I divide 0 by 20, I get my first answer for x being 0. On the other answer, I have negative 3 minus 3, which is negative 6 over 20. Luckily, I have Desmos up here, and I can check to see what fraction that's going to come out to be here. So I'm going to go ahead and do negative 6 divided by 20. And I see that I get a nice blue button here on the left side when I type it in Desmos. You can try yourself, leading me to simplify this fraction to negative 3 over 10 as the most simplified fraction answer. Those are my two answers for x here. For our last example, number 6, we want to solve 2x squared equaling 32. I want to read the note at the bottom of our notes that says we can use factoring if possible, but quadratic formula will always work. So you can actually factor to solve this one if you would like. Go back to our last lesson, last video to check that out. But because this is our quadratic formula video, I'm going to do this one with quadratic formula because it always works, but you could factor this one. We got to get this in standard form. First thing, I got to get it equal to 0, and I just said 2x squared equals 32. So I subtract 32 from one side to the other. Cancels out 32 minus 32 is 0. And I write it in standard form. I'll have the x squared term first. I notice there's no x term, but I do have my number that I will write last. From here, I'm going to look to see if we have a greatest common factor, and indeed we do. I can divide both 2x squared and negative 32 by 2. That would be my greatest common factor. Because it's an equation with an equal sign, I can divide every term by 2, and my result will be actually dividing that out for each term. 2x squared divided by 2 is 2 divided by 2, which is 1. Leave the x squared. Negative 32 divided by 2 is a negative 16, and 0 divided by 2 is 0. Now that we took out the greatest common factor, we can go to our A, B, and C. And remember, if you didn't do that step, you would still get the same answer. This is just going to help you get smaller numbers and take out the greatest common factor, which is always important in factoring. We go ahead and have our A being 2. Our B term will be 0 because I do not have any x's, so I have 0 x's here. But I do have my last number of C, which would be a negative 16. And see what I did there for A? I mistakenly used the one we had before. So I'm going to erase that and change it to 1. So I want to make sure that we are not making that same mistake of having our terms in our numbers of A, B, and C being pulled from what we have written after our greatest common factor step. We go ahead now and go to our formula, which is x equals a negative b. So that would be a negative parentheses 0 in this case, plus or minus our square root of b squared. Instead of b, we'll replace it with 0 squared. Minus 4 will stay, but then we'll change out a to a parentheses 1 and b to a parentheses negative 16. And this will be all over our 2 times a, which is 2 times 1. So again, remember that everywhere we have an a in our formula, we replace it with 1. Everywhere we had a b this time, we replace it with 0. And every place we had a c, we replaced it with negative 16, using parentheses when we replaced all those three numbers. Cleaning up here, we have x equals a negative 0, which 0 is neither positive or negative. So we'll go ahead and leave it as just 0 in front of our plus or minus. We'll go to Desmos to see what's under our square root, but it will be all over here, a 2 times 1, which we know is 2. Let's go to Desmos to figure out what's underneath our radical. So remember too, I can just use the same setup I had for the last problem, just changing out the numbers to match what's under my radical this time. And I see then when I have 0x squared minus 4 times 1 times negative 16, it will be 64. I check to see if I get a whole number when I take that square root of 64, and I do come out to 8. So remember what we did is typed in what's under the radical, replacing it with one number, and then I took the square root of 64 to be 8. I'll keep our options of x equaling a 0 plus or minus that 8 over 2. Now we go ahead and break up to our two answers here. So for the two answers, I have x equals a 0 plus 8 over 2. And I have an x equals 0 minus 8 over 2. We get our numerator down each time to one single number. Do one at a time. We'll do the top one. 0 plus 8 is indeed 8. And when I divide 8 by 2, I get my first answer for x of 4. And then 0 minus 8 is a negative 8, still keeping it over 2. And I divide negative 8 by 2, which is going to be my second answer for x, a negative